Okay, guys, so angle addition. And so listen, there's one sort of golden rule for everything that we're doing today. If you take one angle and you cut it up into smaller parts, the golden rule here is that if you add those smaller parts back together, it's just going to equal the whole. That's all we're saying, okay? If you take a pizza and you cut it into 8, 10, 16 slices, whatever you're going to cut it into, it doesn't matter. If you put all the slices back together, you're right back to the whole pie, right? Even if you only have one slice of pizza, if you decide you're not going to eat the whole thing and you cut it in half, those two together get you the whole slice of pizza that you took originally, right? That's all angle addition is. It's saying the smaller angles added together equal the whole. That's literally it. Okay, so I'm going to put that in sort of, fancy math language, and then I'm going to draw you a picture, and we're going to talk about how to do this. Oh, and before we keep going, I just want you to be crystal clear that I am going to be asking you to submit your work on paper. Well, sort of. I need a picture of your work on paper. You're going to submit that as part of your homework tonight. So I'm going to be very clear about what it is that I expect to see, okay? Because there really hasn't been much work to show yet. You know, like if I ask you, where do these two lines cross? It's just a point. There's no work to show. So today we're starting to have work to show. So whenever there is sort of equations that you need to write and sort of do out, I'm probably going to be asking you to submit that work as part of your grade, okay? So keep that in mind. I'll show you exactly what it is that I need to see, and we will go from there, all right? So first, let's just put this in fancy math language. We're going to say if a ray is in the interior of an angle, it creates two new angles. The sum of those two angles is equal to the original. Angle. Okay, let me give you a minute to jot all that down. And then I'm going to show you in a picture exactly what I'm saying here. Okay, so let me draw you an angle. All right, here's my angle, ABC, and I'm about to come up and break it into smaller parts. So here is my original angle. This is like me taking a slice of pizza, right? And then I'm like, you know what? I'm not that hungry. I'm actually going to cut off some of it. So now I've cut my slice of pizza into two smaller pieces. I have pizza slice 1 and pizza slice 2. So the gist of what we're saying is that if you take these two smaller pieces or angles and add them together, they have to equal the whole original angle that I had before. Doesn't that make sense? Right? If I took something, it was whole, and then I cut it, as long as I put those two pieces back together, I should get right back to the original. So the sort of overarching equation that we're going to be, our model equation for pretty much everything that we're doing today, is that if I just take the measure of angle 1 plus the measure of angle 2, it's going to equal the whole big angle, in this case, ABC. So this is what that's going to look like symbolically, okay? And I know you're looking at this and you're like, what are these M's in front of this? Why is she writing that? When we put a little m in front of an angle, it just means measure of. So the measure of this angle in degrees, whatever it is, plus the measure of this thing in degrees is going to equal the measure of the whole big angle in degrees. That's all that means, okay? So don't get thrown off by a little tiny m there. That just means measure of. And I'm going to be honest with you, sometimes I get lazy and I don't even write the m, so I just write angle 1 plus angle 2 equals angle ABC. And so yeah, if they're there, don't let them throw you off. That's all it means. Okay, so I'm going to try this. And I'm going to try it with just numbers. So we're going to do a few examples that are just numbers. And for those, I'm not really going to need to see your work out. You can provide me your work for that if you want, but they're pretty straightforward because it's just numbers. So I don't really need to see your work until I'm giving you variables. So if you see an expression for an angle, that's when I'm going to need to see something written out. But for this one, I wouldn't really need to see it if I gave you this. So let me give you some information. Let's say if, what do I want the first one to be? Okay. If the measure of angle 1 equals 45 degrees and the measure of angle 2 equals 30 degrees, what is the measure of angle ABC? So this one, I wouldn't expect to see your work because this one's relatively easy. It's just numbers. So you're just going to pop them in. You probably already know the answer. You can call it out if you have it.
75.
75, right? And you can use the equation, but I am just saying this is 45, this is 30, so together they're going to make 70. I will show you how to use the equation because it won't always be this easy. So all I'm going to do is I'm going to just take that model equation. I'm just going to pop in the information that I know. Angle 1 is 45. Angle 2 we said was 30. I don't know what the measure of angle ABC is. That's what I'm trying to find. So, well, that's pretty easy because 45 and 30 is just 75. And now I have my answer. Okay, so something like this, I would not need to see any work done out for. You can give it if you want to, but I don't necessarily need to see it. All right. Let's try, hang on. I just want to see if I did this same example. Yeah, I do want to do this. Okay, try this one. Same sort of scenario. I'm just going to redraw it real quick. A, B, C, angle 1, angle 2. All right, try this one real fast. If I said the following. Try that one. If I told you that angle ABC was 80, and then I told you that angle 1 was 15, can you tell me angle 2? Call it out. Send it to me in the chat.
65.
Yeah, 65. This is another one I mean, you are welcome to submit work here, but I really don't need to see it because all you're doing, this is just numbers. It's actually, while I'm thinking about this, so look how easy it is when I get to just draw on the diagram. So you have a couple of options since I know you're doing all of this digitally, right? That whole thing is 80. Angle 1 is 15, and I'm just trying to find out what angle 2 is. So if you want to actually draw on the diagrams, right, but you're doing this on a tablet or a computer or whatever, what can you do? So I have some suggestions. I guess if you're doing it on a computer, it might be tougher, but if you're on a tablet or on your phone, here's some things you can do to draw on the picture if you want. So first of all, the default, you could always just sketch this on paper, right? If you wanted to actually draw on it. It took me 2 seconds to draw these angles. So you could do that. But I will grant you that sometimes the diagrams are a little bit more complex and it would take too long to redraw it. So I was thinking, what could you do? What could you do, right? If you have a phone or a tablet, you could literally take it and put it inside like a Ziploc bag and then just draw on the Ziploc bag using like a dry erase marker. And then you could just erase the marker. And it wouldn't even get on your screen. And you could draw just like I'm drawing. So that's a great option. You could do that. You could also, you could just use a piece of paper, especially if you have tracing paper, which I don't, but I bet you could use like parchment paper. But even if it's a regular loose leaf sheet of paper, if you turn the brightness all the way up on your screen and you put a paper over top of it, you can usually see through it well enough to see the diagram and make your marks on the paper that way. Isn't that clever? I know. So if you are, or I have a girl B Block that she, on her laptop, she just downloaded some marker tool. So she can literally, just like I do on my iPad, she has some marker tool and she can draw on the diagrams that way. So I don't care how you do it. But if you want to draw on diagrams, those are just some options. I never even thought about putting your tablet in a Ziploc bag. What a good idea. I know. I tell my husband it's the only kind I have. Usually, right? Anyway, so yes, 65 was the right answer to this one. You can use our same formula that we were using before. Angle 1, angle 2, whatever. And that may not always be angles 1 and 2. It's just whatever the smaller angles are going to add together to be the whole angle. So in this case, the whole big angle is ABC. Right? So let's just pop in everything that we know. Angle 1, I do know what it is. It's 15. Angle 2, oh, that's the one I don't know. So I'm just going to leave it. Angle ABC, oh, you're 80. So now I can very easily solve for angle 2 by just subtracting 15. See that? And now I have the measure of angle 2, 65. Yes. Okay. I would not necessarily need to see this written out. If you want to, go for it. But I think most of you are probably just going to look at it and say, oh yeah, I'm just going to subtract. And that's fine with me. I want you to be so confident in math that you don't need to write every single thing down. It would take you forever. I don't want that. I want you to be confident in your math. But any hoosers, there are going to be times where I don't want you to be overconfident. I don't want you to think, oh, look at all these variables. I can do this in my head. You may be able to, but I'm telling you right now, if you just write it out, it's actually way better for many reasons. 1, it uses way less brain power. 2, if you make a mistake, I can actually see what you did. Because I can't see inside your brain. So how would I know where you went wrong? And you're not going to remember where you went wrong, right? If we're looking at it the next day, you're going to be like, I don't know what I did. So let me show you an example of a time that I would want to see some work done out. Let's go ahead, and I got to flip the page here. Let me let Riley back in. Okay, let's try this one. I'm going to give you some angle like this here. Yeah. So, again, I'm not that original, so I'll just call it ABC. Yeah. And I've got angles 1 and 2. Okay, great. So, here's the scenario. This time, we are going to say if the measure of angle ABC equals 122 degrees. The measure of angle 1 equals 4x plus 2. And the measure of angle 2 equals 2x. Find x. Oops, I'm so sorry. I didn't realize I was off. There we go. Okay. So here is your given information. I want you to write an equation that models this and then solve it. So there's really two key things that I'm looking for here. One is the correct equation to start off with. And then, of course, I want your correct final answer. So let me give you a moment. Write your equation. You're doing exactly what we did in the other ones. Take that model equation. I'll even write it here if you want. You're taking this model equation, the two smaller angles, happen to be angles 1 and 2 in this case, and together they're going to add up to be the whole angle. So that's your model equation. So just swap in all the pieces where they go, and that's your equation right there. Once you replace all of these things with what's given in the problem, you have your equation. So that's half the battle. Then you just have to solve it from there. Okie dokie, artichokes. Who can give me their equation? I don't want the final answer yet. I just want the equation. I'll take a volunteer, and if I don't get one, I'll call on someone. But I'd love a volunteer for this one.
Go for it.
4x plus 2x plus 2 equals 122.
You're right. I'm going to reorder what you said just a tiny bit, but you're 100% right. So I'm going to leave it as 4x plus 2 because that's what I have for angle 1. And then I'm going to add 2x. I think you had swapped the 2x and the 2, but you were still right. And then 122 is the whole thing. So I'm hopeful that everybody came up with an equation that looks like that. Now, once you have that equation, you actually kind of get to forget about everything else for a minute and just focus on just that equation. So hopefully, is everybody okay where it came from? Angle 1 is right there. Angle 2 is right there. And then they gave me a value for ABC. So I just popped everything in. And now you get to transport yourself back to Algebra 1. Think what you used to do in Algebra 1. I bet you did algebra, right?
I have a question.
Yeah, go ahead.
Can I say what I think it is?
What, your final answer or what you do know?
What I do know?
Yes, go for it.
Would it be like 6x equals 120?
Yes, I'm going to do it in 2 parts, though. So first, I see 4x and 2x. So let's combine like terms. 4x and 2x is 6x. And then I'm going to subtract the 2. And that's how I'm going to get to what Steve just said. So now I'm minus 2 minus 2. So I get 6x equals 120.
And
right?
x equals 20.
You got it. Just divide both sides by 6, and now I have my answer. So you can sort of take a break from geometry for just a moment while you're doing this algebra out. Now, let's say that this were a question on the homework. What I really need to see is this whole chunk. All right, so I want to see your original equation, and then I want to see you solving that equation. Okay, now your homework is going to be on delta, so you're still going to type in delta 20 as your answer, but there is no way for you to submit work on delta. That's why you're going to do that on Jupyter. I know it's annoying that you got to do one thing here, one thing over there. I feel you. Believe me, okay? I'm with you there. I wish that there was just one massive thing that I could do everything on, and oh, trust me, it would make my life a lot easier too. But if you wouldn't mind bearing with me, and helping me out here. So then I can at least see what you're doing, and it'll be so much easier for me to help you too if I can just see, oh yeah, like it was just this little thing that you did wrong, or oh, okay, you have absolutely no idea what I'm talking about. Okay, but that's useful, right? Then I know where to go from there. Okay, so let's try another one. Let's do this one. Okay, so I'm going to give you another picture. I'm going to draw it kind of over here. And I'm going to try and save you from making a very common mistake. I'm going to call this angle CDE just to be a little different because it's not always ABC. All right, so here's the situation with this one. I'm going to tell you, let's stick it down here. If measure of angle 1 is 5x minus 10. Measure of angle 2 is 3x plus 2. All right, so here is our situation this time. And the one thing that I don't want you to, the trap I don't want you to fall into, I don't want you coming in here looking at angle CDE and saying, oh, that's a 90-degree angle. What? Who said it was? Not me. Nowhere on here does it designate that it's a 90-degree angle. Even if it looks like it could be, it doesn't matter. We go off of the numbers. So if you see down here in the directions, I guess you would call them, I told you it's a 72-degree angle. So no matter what angle CDE looks like, it's 72 degrees. I don't care if I drew a giant obtuse angle and I told you it was 72 degrees. You have to go off of the numbers, not how it looks. Okay? They will try and trick you sometimes and give you an angle that looks like it's obtuse, but it's really acute or whatever. You always go off of what is written, the numbers, not looks. Okay? So everybody try this one. You should be able to solve for x here. If it is helpful, I will write sort of our model equation again. So I'm just looking and I'm saying, okay, I have these two smaller angles, 1 and 2. Together, they're going to get me the whole thing. That's my model equation. Okay, so I'm just going to say, all right, angle 1 and angle 2 together are going to get me angle CDE in this case, because that's my whole big angle.
Could I answer it?
Yeah, go ahead.
So combining them together, you get 8x minus 8. So you minus 8 to 72, you get 64. 8x into 64 is 8, so x equals 8.
So if you had submitted all your work to me, which I'm sure you will, I would know exactly where you went wrong. And the only place where you went wrong was right here. When you did, I'll show you, because I'm gonna write out the whole equation. I'll show you, and then it's so easy. I know right away. The answer's well, hold on. Let's go back. Angle 1 is 5x minus 10, right? So I want to see that. Plus angle 2 is 3x plus 2, and then the whole angle is 72, right? Okay. Now watch. Forget the diagram. Forget everything. Let's just.
Yeah, I already know where I went wrong too. Yeah.
All right, so now tell me, what do I get when I do combine this left-hand side? What does that become?
The left-hand side becomes 8x minus 8.
Yes.
And you do add 8 to instead of minus 8 to the 72, which would make it 80. And then 8x divided by 80 is 10. Perfect.
So this is a great example. Like I would know in 3 seconds that was just a little math error. Right? He clearly knew the basics of what he was supposed to be doing. He knew he was supposed to add this angle plus this angle equals the whole angle. So that's, I mean, we all make little math errors, but I know that he knows what he's supposed to be doing. And it's not a, okay, hold on, we need to backtrack. You have no idea, right? So again, if this were a homework question, what do I want to see? I want to see basically this whole chunk. That's what I'm looking for. So I do want to see this equation before you have combined it. So then I know, like, was there an error? Where's the error, right? Because if you don't give me this top line and it's just here, if something was wrong, it's harder for me to know. So if you could just spend the extra literally 2 seconds and write this guy too, then I can see everything. And you don't have a ton of questions, so this is, it's not going to take you 7 years. Okay, let's try another one. I'm going to switch things up on you a little bit. Or do I want to do this yet? Yeah, I'll switch the... No, you know what? I'm going to do this. Because I don't want to forget it. Oops, I got to turn the page this way. I'm going to make one up, so the numbers may or may not come out nice. I tried in the last block, and I thought I had it, and then when I actually did it, I was like, oh, they're not nice at all. What happens if you have an angle that's broken up into more than just 2 parts? What if you have 3 parts? Well, it really doesn't matter. You're still going to operate the same way. I'm still just going to add all the angles together and set it equal to the whole. Okay, so let me give you some values here. And I'm going to draw them right on the diagram. Let's say that angle 3 is 4x. Let's try this again. This one, let's make it 2x plus 10. And then this one, I think I mean for it to be 4x. Oh, yeah, why not? That can be 4x. So, yeah, whatever. That's fine. Those can be the same. Why not? And let's say that the whole angle is 110 degrees. Okay, so see if given all of this information, can you find x?
I have the equation.
Tell me. Well, hold on. Actually, before you tell me, I'm going to write just my general. I'm going to add all 3 angles together this time because there's 3 of them. And all together, they're still going to equal the whole big angle, which in this case is x, y, z.
Would it be 10?
Got an offer for 10 here.
So, yes. Okay, 10. Steve, tell me the equation, and let's see if we do end up getting 10.
4x plus 2x plus 10 plus another 4x equals
It's up here.
yeah, 110.
Yeah, 110. So that first step, you're literally just popping in everything that they gave you. So now let's forget about the diagram. Let's forget about everything. Let's just look at the equation and just solve it using your algebra skills that you all have. 4x and 2x is 6x plus another 4x. So if you combine all those like terms, you get 10x. You still have a plus 10 equals 110 on the side. And now it's a simpler equation. You're just going to solve like you always do. So you get 10x equals 100. And then it just so happens that this one works out really nice. The last one was not so nice, but this one is. Yay! It comes out to be 10. So no matter how many parts it's divided up to, it doesn't matter. I'm just going to take all the small pieces and add them all together, and it's got to equal the whole angle. Okay? So now I'm going to switch things up on you a little bit, and let's try this. All right, let me draw you this picture. Okay, so here's my diagram, and I'm going to tell you the following. If the measure of angle 1 equals 30, measure of angle 2 equals 4x plus 10, and the measure of angle ABC is equal to 6x plus 20, find x. All right, everybody, try this one. Let me cover this up so you don't get confused. We're not looking at that anymore. Just gonna make this a little darker. Okay, everybody give this one a go. If it helps you to write that model equation, you should do that. I find it very helpful. So in fact, I'm even going to sneak it on here. So what do I mean by when I'm saying model equation? I'm saying, okay, just look at this. Isn't it going to be true that these two angles add together to be the whole angle? That's the model equation. Angle 1 plus angle 2 equals all of angle ABC. So before you don't even have to read this gibberish to come up with that. You can see that right from the diagram. Those two angles have to add together to be ABC. Okay, great. Now I'm going to read the gibberish and I'm going to pop in all of the values that I have. Okay, so can someone please share with me what their equation is for this?
Yeah.
Go ahead.
I have 4x plus 40 equals 6x plus 20.
So you're not wrong, but you're combining these two.
Yep.
You know what I mean? So do me a favor and just don't combine them yet. So I have 30 for angle 1, and then angle 2 is this 4x plus 10. So he's right that when I do combine that, I'm going to get exactly what he said there. So there's me literally just popping in each of the three values. I know what angle 1 is. I know what angle 2 is. I know what angle ABC is. Or at least I should say I have an expression for them. I mean, I do happen to know what angle 1 is, but the other two, I have something to put in for angle 2 and something to put in for angle ABC. Perfect. Now it's literally just an algebra problem. You could have solved this last semester now. So I'm just looking at this, and he's going to combine the 30 and the 10 because they are like terms. So I get 4x plus 40. And now, ladies and gentlemen, it is simply a matter of solving this equation correctly. So remember how you do that. If you have x's on both sides, like I do here, I have 4x on the left and 6x on the right. I need to get the x's together. You can't have x's all over the place. So I would think that the easiest thing to do is minus 4x from both sides. Could you have minus 6x? You can. But then you're going to have a negative 2x on your hands, and I don't want to deal with a negative if I don't have to. But you're not wrong if you do it that way. It doesn't matter. So you should get another reason why if you show me your work, I can very easily see, so if you had subtracted 6x instead, it's fine as long as you do the rest of it right. And now I'm here, and I'm like, oh, okay, now it's easy. So I'm just going to minus 20, yeah. I get 20 equals 2x. And now I can just divide both sides by 2. It just so happens that we ended up getting an answer of 10 again. The answer will not always be 10, obviously. But 10's usually an easy number for me when I have to make the equations up. Sometimes it's easy to just stick with multiples of 10 when I'm making the numbers. So I know it works.
I have a question.
Yeah, go ahead.
Well, it's not really a question, but so I didn't put 30. I put the measure of 2 and then the measure of ABC. So I think that's where I went wrong because I got 0 for x.
Oh, yeah. So you have to have that 30 for angle 1 because,
Okay.
Yeah. Wait, hold on. So what was your equation? Go back. Tell me the equation.
4x plus 10 plus 6x plus 20.
Oh.
Yeah, I just never put the 30 in the front.
Yeah. So, and do you realize why that's wrong? Because think about what you're saying. Look in the diagram. You're saying that angle 2 plus angle ABC equals this angle,
Oh, okay.
right? And that doesn't make sense. So you always want to make sure that you're adding the two smaller angles together, whatever they are, and they're always going to equal the big angle, in this case, ABC.
Okay, thanks.
You're welcome. Okay, so I have one last thing to talk to you about, and then we're done. And it is the word bisect, which I know we've talked about bisect with segments. So now let's just briefly take a look at bisecting angles. So I just want to make sure that I re-emphasize bisect means to divide into two equal parts. That's the key. They have to be equal. That's what bisect means. It doesn't just, so a lot of the other problems that you saw, I just divided into two parts. They weren't necessarily the same, but if I literally use the word bisect, that means that I'm going to take this angle, whatever it is, and I'm going to cut it exactly in half. Okay, so listen. Right now, you have no idea if I have bisected angle ABC or not. Just because it looks like those two could be equal doesn't mean that they are. Nothing has said that this particular angle has gotten bisected. So how do I tell you? How do I let you know that I really am bisecting this angle? There's a couple different ways. One way is I could come over here and I could literally say BD bisects angle ABC. If I say it in words like that, now you know, oh, okay, so this is cutting the angle exactly in half. So what does that mean? These two angles have to be equal to each other. All right? You can't go around just assuming the angles are equal unless you have something to back it up. Bisecting backs it up. All right, so we can say angle 1 is congruent to angle 2. Another way that I could sort of just, convey this same information is I could actually just mark it on the diagram. Remember those congruents, like we use arcs for angles? So if I mark them with both a single arc, that would mean that they are equal to each other. All right, so if I have that in the diagram, that's another way to know for sure that the whole angle has gotten bisected. And those two angles are going to be equal. All right, so let me ask you this question real quick. Feel free to shout out the answer. If angle ABC is 40, what's angle 1?
20.
20, of course. Okay, let's flip it now. Let's pretend that angle 2 is 30. What is angle ABC's measure?
60.
That's it. That's it. So just be mindful, if you see bisect, you need to know that means it cuts it into two equal parts. Okay, so that's it for the notes, believe it or not. So what I do want to do is I'm going to grab the homework real quick because just the very first question is a little bit different. It's kind of more just for fun. I think it's fun anyway. I think everything's fun though, right? So if it's math related, it's probably fun. How could it not be? All right, so let me just grab your homework real quick. Let me get the camera out of my face. Okay, and let me share this with you. What? Oh, there we go. Okay, so when you come in here to look at your homework, the very first one is one of the computer-generated ones, angle bisector. Okay, watch what you do with this. I think it's fun. It's kind of a game. I think of it as a game anyway. They're going to give you some random angle, and you're going to try and draw the bisector. So here's what you do. You grab the yellow dot, and you click on it, and look, it's going to, you have some ray now. So you're going to try and bisect this angle as best you can. Oh, this one's kind of hard. So you're going to try and, I'm going to come in a little bit closer. And you want to just guess. Oh, I'm going to go with it right there. You're going to see how close you can get to like perfectly bisecting it. Oh, am I? Oh, that one's really close. Oh, I'm off by one degree though. So it's going to give you a right answer if you're within like, I think it's 2 degrees or something like that, maybe 3 degrees. So it'll give you the right answer, but I like to try and get it like exactly. So I'm off by 1. I'm going to try another one.
Didn't it say 5
Did it? Oh, can I go back?
in the direct?
Oh yeah, they have to do it 5 times.
Yeah, within 5.
Oh. Oh, within 5 degrees. Oh, you got a lot of leeway then. Okay, so I'm going to try it again. But if you get it perfect, it's kind of exciting. That one looks good. All right, I'm going to try it. Come on. Oh, see, I'm a little bit off. But I still get it marked right because I'm close. But shoot for, see how many of them you can get perfectly. I'm off by 1 degree. I'll try one more time. It's so exciting. I tell you, the first time I did it, it probably took me like 10 tries to get it spot on. I'm going to go with that. Come on. Oh, that one's worse. I'm up by 2 degrees there. So any Hoosers, I hope that you like that one. It's like a game. All right, but then after that, it's just going to ask you more typical questions. So let me zoom in and I'll walk you through one like this, for example. Okay, and this is what I'm talking about. If it's helpful for you to just, you know, put your tablet or your phone in a Ziploc bag and draw on it with a marker, or use a piece of paper and just put it over top your screen and then you can kind of mark on it. So if something like that is helpful for you for a problem like this, then do it. Do it. You're totally welcome to. Just please, if you're using one of our tablets, just be careful that you don't press too hard, right? I'd prefer you use pencil than pen if you're doing that. And just draw real lightly, okay, please? All right, so anyway, BFC is this angle right here, BFC. So here it is. Just going to darken that a little bit. And they're telling me that it's 35. AFC now. AFC. So that's this whole thing. I never know how to, there we go. AFC. A to F to C. That's this whole thing. They're saying is 78. And the question is, find the measure of angle 1. So something like this, again, I don't need to see you writing the equation out, because hopefully you're looking at this and you're like, oh, I'm just going to do 78 minus 35 and get my answer, right? You're probably not going to write an equation here. Can you? Absolutely. But I don't need to see it if it's just numbers. All right, so that's going to get me 43. So you're fine to just pop a 43 in there. And yep, that looks good. Okay, I'm going to jump down a little bit and try another one. Let's see, what do you got? This random one here. Okay, so here's another one that's just numbers, so I wouldn't necessarily need to see this. HLJ is 70. HLJ, there you are. H to L to J. So this whole thing is 70. And what else? GLJ. Oh, GLJ is 90. Okay, so this whole thing, G to L to J, all of that is 90. And the question is, find GLH. So I'm trying to figure out, okay, well, what's just this little piece? So if the whole piece of the pie is 90 and this section is 70, that means that other little piece has got to be 20, right? I'm just going to do 90 minus 70 and I get my 20 there. Okay, so let me put a 20 in there. Yes. So I'm going to jump way down because I think it's really towards the end that you're going to get some that you need to. All right, so here's one. I would need you to give me your equation for this one, because this one, see how it has x's in it? So anything with variables, I would like to see the problem done out. Now, I don't think on Delta it tells you like what problem number you're on, which is super annoying, because obviously I would like you to number your work so I could go back to it. If there is no number, which I don't think that there is, then whatever, I'll figure it out. You know, I'll be able to tell based on your numbers what problem you're working on. So if you can keep the question number, great. And if you can't, whatever. It is what it is. All right. So let's see. I'm going to do this one. So I know the angles 1, 2, and 3 all together are going to add up to be the entire angle. So I would come in. So what I'm showing on the, if I'm you, this is what I'm writing on my paper. I'm writing angle 1 plus angle 2 plus angle 3 equals the whole angle, 180. So I would, if you want to write the model equation, that's great. But if you don't, as long as you give me this, I'm okay with that because I will be able to tell what your model equation was, right? And now I want you to combine like terms. So 3x and 2x is 5x and 4. I've got 9x equals 180. Divide both sides by 9. X is 20. So I still do need you to just come down here and type in your answer.
Before you submit, Miss Sabia,
Yeah.
can I just point out, guys, she's talking about don't look at it and assume. A, B, C, they list as 180 degrees. That's supposed to be a straight line, but that's not what they picture. You got to collect your facts. Go by the facts, not by your feel.
Yes. Thank you for pointing that out. Yeah. You always go off of the numbers. Always the numbers. So yeah, you're right. That should look like a straight line. It doesn't. Doesn't matter. I'm going to use the numbers that they gave me. Okay. So still come on down here, and I do need you to submit 20 like you always do. So the only additional thing I need you guys to do when you are done with the assignment, you're just going to take a picture of your work and then just submit that on Jupyter. Okay. Does anybody have any questions right now about how to do anything or? Does everybody know how to submit on Jupyter? I know you had to do it for Mrs. Swanson last semester, so I know many of you already know how. I think it's fairly easy, right? Don't you just like click it? Click a thing and you take your...
I haven't had to submit on Jupyter.
What was that?
What was what? What did I miss? I heard someone say that they hadn't had to submit on Jupyter.
Okay. Was that you, Sophia?
Yeah.
So try it now. Go into Jupyter, and when you look at this assignment, let me make sure that I turned it on for you guys, though. Hold on. It should be. 3.3 angle addition. Yes, this is ready to go. So when you go to Jupyter, you should see an option to submit your, like attach a file or something. And you can just take a picture of your work. Okay, try it. This is our first time, so we'll see how it goes. I still don't know